Your brain's a signal processor. It's receiving signals all the time from the sensory surfaces of the body, and then it's got to do something with those signals to make sense of them. That's what's real. And every experience you have as a consequence, including emotions, is real in that way.
But we're constructing the whole ball of wax, the feeling and the emotion.
We are constructing the whole ball of wax. So your brain is trying to do its job in the most metabolically efficient way, and it's trying to direct the body to do its job in the most metabolically efficient way. So you can think about what the brain is doing is running a budget for the body, because it costs something to keep your cells alive. Sometimes when you feel uncomfortable, Larry, sometimes when you feel bad, it doesn't mean something is wrong. It means you're doing something really hard.
Welcome to the Balance Podcast. I'm Larry Weeks. Today I'm speaking with Dr. Lisa Feldman Barrett, a psychology professor and neuroscientist at Northeastern University, who is the author of 7 books on emotion and the brain, including the best-selling book, How Emotions Are Made, and most recently, 7.5 Lessons About the Brain. In addition to the books, Dr. Barrett has published over 260 peer-reviewed scientific papers, and she received a National Institutes of Health Directors Pioneer Award for her revolutionary research on emotion in the brain. Her popular TED Talk, and I highly recommend you check it out, titled You Aren't at the Mercy of Your Emotions, has almost 7 million views. So on this episode, we discuss her groundbreaking theory of constructed emotion, which overturns many prior assumptions about how the human brain works in forming emotion. And as you listen to the audio, you will notice we jump right into the subject matter in a bit out of order. So let me try to lay some groundwork up front here that might be helpful. So the theory of constructed emotion suggests that our brains create emotion in the moment predictably from a mix of physical and psychological elements. And her research shows that what exists in the brain and body is affect, an expression of feeling. And in her words, and I quote, "In every waking moment, your brain uses past experience, organized as concepts, to guide your actions and give your sensations meaning. When the concepts involved are emotion concepts, your brain constructs instances of emotion." So the bottom line here is you don't experience the world as it is, you experience the world through affect-colored glasses. So this also contradicts many of our most firmly held beliefs about emotions, like the idea that emotions are innate or hardwired in an ancient reptilian part of the brain. And let me cross some T's here on terminology as well. We talk about something called the body budget. And the body budget refers to the idea that our bodies have a limited amount of energy to expend on emotional experiences. The body budget is the amount of physiological energy that our bodies have to expend on experience. And she says the brain's core function is to regulate complex needs in the body versus purely thinking. Dr. Barrett says we can't overcome emotion purely through rational thinking because the state of your body budget is the basis for every thought and perception you have. Okay, now that I've either laid the groundwork or totally overwhelmed you, let's get into the show. So on this episode, we discuss those concepts that I just kind of laid out. We talk about what theory means in a scientific context and the evidence for the theory of constructed emotion. We have an overview of her research about the theory. We talk about the classical view of emotions. She dispels some myths about emotions that are out there. We talk about the problem with the amygdala hijack, which I mentioned, and the reptilian brain. We talk about the brain as a prediction machine. We talk about rationality and emotion, mood and metabolic efficiency, emotion and body budget deficits, how emotions can be deconstructed or recategorized, a new take on depression, and she tells the story of her daughter and the concept of an emotional flu. And then we talk about decision-making and emotions and how they interplay there. So there's a lot here, and I think you'll find it as fascinating as I do. So now I give you Dr. Barrett. First, I want to say that looking at your background, psychophysiology, is that unambiguous? I mean, it's straightforward, the relationship between physiology and psychology?
Basically, yes.
Okay. And over the last, correct me if I'm wrong, 26 years or so, your team at the Interdisciplinary Affective Science Laboratory at Northeastern University, you studied faces, bodies, brains of thousands of subjects around this topic that we're going to talk about to unlock the emotional brain.
Well, I don't think there is anything called an emotional brain. Some people think, they talk about the cognitive brain, the emotional brain, the social brain. I think you just have one brain that can do a lot of things. But yes, we've studied faces and bodies and brains, and we've studied lots of ways that scientists believe it is possible to measure emotion. And we've also done very large summaries of research. So there's a technique called meta-analysis, which is exactly what it sounds like. You just take hundreds and hundreds of studies from thousands and thousands and thousands of test subjects, and you summarize the results in order to see what, if anything, is replicable and consistent across studies.
Let me dive in. I read 2 of your books, How Emotions Are Made, and then 7 Lessons About the Brain.
7.5.
7.5. Okay. 7.5 lessons about the brain. And they're tied together, I believe, right? But let's talk about the theory of emotions. And I know you've talked about this probably a million times, but let me proffer what the theory is and jump in and carve out what's correct here. So simply put, your theory is that emotions are constructed rather than innate. Is that right?
Yes, that's correct. But I just want to make a caveat when I say that, the colloquial use of the word theory means some stuff I believe or some stuff I think might be true. But in science, a theory is a set of ideas that you put to the test many, 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 many times with lots and lots and lots and lots of different studies. So when I call something a theory, I'm basically saying this is a set of ideas that there's a lot of support for and that we so far haven't been able to disconfirm, right? So when people talk about the theory of evolution or the theory of natural selection, that's not just a bunch of ideas that somebody pulled out of their ear or any other orifice of their body, a set of ideas where there's a lot of data to support those ideas. And so the theory of constructed emotion is a theory in that sense. It's been tested. It still requires more testing because in science, we never say, okay, we've proven anything, right? It still requires more testing, but so far it's proven to be really quite robust.
Is there a better word than theory?
Well, I think the thing is that people use the word theory in everyday life the way a scientist would use the word hypothesis. So when I have for a long time, I didn't have a theory of anything. What I knew was that the data, the published findings, didn't match the claims that were being made about how emotions work and what kind of phenomena they were. So you'll see people make claims about how emotions are innate or how emotions are triggered by triggered by things that happen in the world, and that there are these circuits that are very specific for anger, sadness, fear that are in your brain and that are preserved across, humans and animals, other animals, or that, facial movements are universal, the way we express emotions universal. And people make these claims. And when I came to the field, I had read these claims and I believed them because why would I question them? These are published claims and they're in textbooks and so on. But I had a reason to go looking in the literature, the peer-reviewed published literature. And what I found was nothing like what those claims would look like. No, the evidence just doesn't support those claims. And so what that led me to do was systematically, so I needed to understand how facial movements work. So I learned that and then was able to run my own experiments. So I needed to understand how physiology in the body works, like how your cardiovascular system works, your respiratory system works, your immune system works. Okay, so I had to learn that so that I could run my own studies and I could better understand the published literature. And then, I had to understand something about the brain. And so I just kind of systematically picked off one domain after another. First, just trying to understand what have scientists observed? How are they understanding what they observe? And it took me a long time to piece together what I thought was happening. But even then, it wasn't a theory. It was a set of hypotheses. A hypothesis is an idea that you expose to observation to test it, to see, does it hold water? Can it actually predict anything? Does it account for what you're observing? And as a scientist, what you try to do is prove yourself wrong. You construct these very risky experiments, meaning you're putting your own ideas at risk. You're trying to show that you're wrong. And if you can't show that you're wrong, and you've accumulating evidence which is consistent with your view, then you're more likely to be right. Although there are some questions in philosophy of science about just how confident you can ever be about your hypothesis, but that's a whole other kettle of fish.
So let's talk about the view of constructed emotions compared to the classical view, if you will. And has it pretty much supplanted the classical view? And are these views still competing as to, in the scientific community or the psychological?
Yeah. So I think it's important to understand that when historians and philosophers look at how science proceeds, like in physics and chemistry, in whatever, it often doesn't happen that a new view supplants an old view. Sometimes it happens, but often it doesn't. And they proceed in parallel for a really long time. And then some philosophers and historians think that's a good idea, and others think it's a bad idea. So, that's the backdrop against which we're going to talk about this. So there's this one view of science, which is that, scientists discard ideas that are old and not useful, and they accumulate knowledge so that their ideas get better and better and better, approaching the truth. That's just a myth. That's not really how science works. And there are a lot of reasons for that. So that's the backdrop again. So occasionally you have like a revolution where there's a whole massive shift, like people talk about the Copernican revolution in understanding the solar system, and the Darwinian revolution in understanding evolution. And those are real scientific revolutions, but they don't happen all that often. And the theory of constructed emotion, the ideas I have about emotion, which are, I think, very well supported, I think we're in the middle of something that we won't know whether it's a revolution or not until it's over. And that actually matches even how we understand revolutions in politics. Like when you're in the middle of a revolution, you don't know that you're in the middle of it until when it's over. That's when you know it was a revolution. Mm-hmm. And it's not over yet in the science of emotion. So what I would say is that I'll tell you what one of my former postdoctoral fellows said to me 30 years ago. Before I started my own lab, there were maybe one or two people who were working in the domain of emotion who were challenging the idea that emotions were innate and universal. Most scientists believe that emotions were innate and universal. That means shared by all humans, arising from circuits, like almost in a reflexive or obligatory fashion, in a way that is common across different animals, but that humans had this extra capacity to regulate emotions after they kind of bubbled up, and maybe even to prevent them from bubbling up. But once they were triggered, they would cause an obligatory facial expression that everyone around the world made and could recognize, that the triggering of an emotion would cause a very specific bodily state, where your heart and your lungs and your gut and so on did very specific things. And that's what people believed. And there were maybe one or two labs where people didn't believe that. That's not what they were hypothesizing. That's not the kinds of experiments that they were running. Now, if you look at things, there are dozens and dozens of labs who don't take that view. And I heard recently from someone, like literally on Friday, I was talking to somebody who said, I was at a party the other day and I heard this older neuroscientist saying, he remembered you coming to give a talk at his university when you were a young person, and how everybody laughed at you because they thought your ideas were crazy and that you were just nuts. He said to me, now look, your view is one of the two dominant views in the field. And he said, nobody could have predicted that. Now, there are many ways to think about that, but the way I think about it is the following. The history of science tells us that scientists sometimes hang on to ideas longer then those ideas are viable, meaning the evidence is already in that those ideas don't work so well. Scientists have a hard time giving them up. And some ideas, which scientists think are absolutely crazy, just batshit crazy ideas, turn out to be ideas that hold water. But it takes a while. Like germ theory, people believe that germ theory took 100 years before people or something, and there are just tons of examples like this, right? So I try to cultivate patience. I mean, I think that there should have been a scientific revolution and it should have already been over. And we should be on to we should be in a period of normal science where we're using more constructionist ideas. Because these are ideas that are firmly grounded in physiology and in neuroscience, in biology and chemistry and so on. I think that's where we should be as a field, but it isn't where we are.
Right. Well, and as we get into it, because there's a reason where this preamble is happening, because it has profound impact to mental health and therapies, and I would think, right, the downstream.
Oh, for sure.
And, I mean, it's nowhere near the understanding, it seems to me, in the general populace as to how emotions come about.
Well, I guess what I would say is there are some treatments out there that work for treating, mood disorders, for example, that work pretty well. But the clinicians, what they believe, their beliefs about why those treatments work are wrong. Like, so you could take The Body Keeps the Score. This book has been on the New York Times bestseller list for 2 years. Okay. The recommendations in the book work. They seem to work for not everybody, but portions of the population are helped by some of these techniques. But the explanation in that book for why they're helped is absolutely categorically incorrect. To my best understanding of neuroscience, and not all of this is my data, it's just, evidence that's out there, the explanation for why they work is wrong. And you may not think that matters, but it does matter. It matters because when people try to generalize a strategy from, let's say you learn a strategy to help with one thing, and then you try to take that strategy and use it somewhere else like a tool. If you don't understand how it works, you're not going to be able to generalize it very well. So, for example, I don't know whether the pandemic is over or not, or whatever. After it went on for a while, you started to see people talking about how they were languishing and how they had malaise. And the explanation was that, it's because your fight and flight circuits are like overworked or overrun. Well, you don't have fight or flight circuits in your brain, okay? The circuits that are supposedly called fight or flight circuits are circuits that are engaged when you remember a phone number. Now, granted, for some of us, as we get older, that's a really tricky thing to remember a phone number, right? It's really stressful. But the point is that
quickly, and you need to get it quickly. Yeah.
Those circuits, really what they're for, are regulating and coordinating the systems of your body, and they're always engaged. It's just that if you want to really ramp those circuits up and drive them really hard, you put animals in situations where they have to flee from a predator or they have to fight, for food or for a mate or something like that. But that doesn't mean that those circuits are fight or flight circuits. It means that the circuits are important for regulating the body, no matter what you're doing. So the explanation for why people are feeling malaise is a very different explanation than, your fight or flight circuits are fatigued because they're overworked or whatever. And what you do about the situation is very different based on your understanding. So I think that's the important thing here. If you think emotions are triggered, then there are one set of things that you do. And if you believe that your brain makes emotions, constructs emotions, assembles them for a particular purpose in a particular way, then that leads you to do other things, different things, to take care of yourself and try to manage your emotional life.
Okay. And I want to talk about those things and your opinions of those things. But since you touched on it, one of the classical views is that humans are at the mercy of the emotional circuits buried deep within an animalistic parts of a highly evolved brain, right? And so you're rejecting that notion that categories of emotions such as, fear, anger, sadness would take place in distinct brain locations. Is that right?
Well, there's no evidence that. Okay. Yeah, there's just no evidence for that.
Right.
And there's no evidence that you have some deeply animalistic part of your brain. There's no evidence that you have a limbic system, which is ancient.
You talk about the layered brain. You talk about the triune brain, the layered brain, and you're saying there's no evidence of that. And what's in the jet stream of the culture is this hardwired ancient reptilian part of the brain. People talk about that all the time, or the amygdala. You hold that.
But I'll tell you that even the person, Joe Ledoux, who's a really good scientist, even that person who came up with the idea of amygdala hijacking has renounced it. But just so we're clear.
Oh,
he no longer thinks that's what's happening. And so, that you have this fear center. So many scientists, so this is the other thing I think is important to understand, is that when scientists, it's normal to be wrong in science. There is a place for being wrong about things in science. It doesn't mean that you're not a good scientist.
Oh no, that's that's how you get to the truth is.
Right. When you're wrong about something, it's like nature just handed you a gift because it's an opportunity to discover something new. I've been wrong about things. And I have to say that a number of my colleagues who used to believe that the amygdala was the fear center and that it was in this ancient part of the brain and that it was hijacked and so on and so forth, don't believe that anymore because the evidence doesn't support it. There are these really nice studies that were done by my colleague, Ralph Adolphs at Caltech. And he was able to look at amygdala neuron firing in humans, live humans, who are in the hospital waiting for surgery for epilepsy. And so brain surgery for epilepsy is a very tricky thing. And you have to basically, before the surgery, you got to stick electrodes in people's brains so you can measure actual firing of neurons in humans. And they have to check all kinds of things like which are the parts of the brain that are important for you, for language and so on, because it's not the same for everybody. So they do all these experiments on people before they do the surgery. In order to do the surgery, they have to destroy some tissue. They want to minimally destroy the absolute, most smallest amount. So my colleague Ralph Adolphs did these studies where he showed people images and to evoke fear in them. And he measured amygdala active, like the firing in the amygdala and some other parts of the brain. And he found that amygdala neurons fire 300 to 600 milliseconds after the onset of, looking at something scary like a spider or a snake or whatever. And only after other parts of the brain, their neurons for example, in prefrontal cortex had started firing first. Now, if amygdala neurons really were the neurons for fear could never keep you alive. 600 milliseconds. I mean, it takes you, 300 milliseconds to blink. So actually to sort of make a motor plan to run away, that takes considerably longer than 600 milliseconds to actually make a plan to run and then for your brain to plan the motor movements and then to actually execute them takes longer than 600 milliseconds. So you would be dead if you were really depending on that circuitry to keep you alive in the face of threat. That's just not what amygdala neurons are doing. And that's just one example of many, many, many studies which clearly show that amygdala neurons are not dedicated to computing or triggering fear.
And by the way, that's the other myth. You just mentioned it, or part of it's wrapped up in there, that emotions are in fact made. They're not triggered. So let's use, if we can, Lisa, the amygdala hijack, because most of my friends, they've used the phrase. I'm sure I've used it. So if that's not happening, if the amygdala is not being hijacked, tell us in your theory of the constructed emotions, what is happening?
The first thing to understand is the answer to your question is not simple. So the classical view of emotions where you see a snake, it triggers fear, you scream, you make a face, your heart rate rises and you run away. That's a real simple story. Okay. But actually what's happening is not so simple. It's definitely understandable, or at least there are parts of it that we understand really well, but it's not a simple story. So the story is really more something like this, that you don't react to anything in the world. Your brain is predicting everything that is going to happen. It's attempting to predict what's going to happen next. And It's attempting to predict what you need to do next, what you're going to see next, hear next, feel next, smell next. So that's the way the brain is structured. That's what's most metabolically efficient for a brain, the way for a brain to work. It's predicting. It's basically using the present and asking itself metaphorically, well, the last time I was in a situation like this, where I saw certain things and smelled certain things and did certain things, what happened next? And it attempts to remember or reassemble patterns that were similar to the past. And in psychology, things that are similar are called a category. So what your brain is doing is it's
trying to be efficient, right?
It's making yeah. And the reason why it's doing this is the following. Okay, your brain is trapped inside a dark, silent box called your skull. Your brain is only receiving sense data, sensory signals from the sensory surfaces of your body, your eyes, your retina in your eyes, your cochlea in your ears, all the sensory surfaces on your body and in your body for glucose, salt, water, what have you. When light hits your retina or sound waves, like changes in air pressure hit your cochlea, the signals go to your brain. Those signals are the outcomes of some cause, but your brain doesn't know what the cause is. It only knows the outcome. It has to guess at the cause. That's called a reverse inference problem or just an inverse problem. If you hear a loud bang, you don't know what the bang is. It could be a car backfiring. It could be thunder. It could be a door slamming in the wind. It could be a gunshot. What you need to do depends on what the cause of that sound is, but you don't know the cause. You have to guess. And so what your brain is doing is it's attempting to guess in order to reduce the uncertainty. If you don't know at all, your brain has to try to plan a myriad of actions, which is difficult and metabolically expensive. But if you can narrow down the uncertainty to one or two things, then it's much easier for your brain to plan effectively an action, to make an action plan to keep you alive. And so your brain is making these guesses, and it's making these guesses before the sense data actually hit your cochlea, meaning your brain is anticipating, it's guessing what
you're having a physical response before.
Yeah, it starts
conscious.
To prepare. Yeah, exactly. So, when I'm talking to audiences and I want to demonstrate this, I can do it visually. Like I show them a blobby image that they've never seen before, black and white blobs, and they can't see anything except black and white blobs. So they're experientially blind.
Oh, yeah, that's a TEDx talk. I saw that. Yes.
It was a TED talk, yeah. And then I show them something, and then I give them an experience, and then I show them the black and white blobby image again, and poof, they see now an object.
It was a snake, I believe. It was.
Well, you just gave it away, but
oh, sorry.
Yeah. So no, that's okay, because you know what? If you look at the blobby image, and I tell you, oh, that's a snake, it won't help you. You still can't see the snake
until you.
So the point is that before, when they're only seeing blobs, and afterwards, where they see the same blobs, it's the same image on the screen, the same information, but they see a snake. The only difference there is what's in their heads, because what's on the screen is identical, right?
I'm going to edit in on the video. I'll put the image in there.
So when you put so the way I do it, you saw, which is you put the image and then you show the photograph and then you put the image again. And when you do that, people have this aha experience. You can hear it. I mean, like I've used bees, I've used snakes, I've used all kinds of things. And the reason why I'm using those images is that those are images that when you show people the actual photograph, you get a heart rate change, you get skin conductance change. Like, people start to sweat and they start to breathe more quickly and their heart starts to race, because a prediction isn't just an abstract thing. Your brain is changing the plan for actual physical changes in your body. Okay. And the literal copies of those changes are sent to the sensory areas of your brain to prepare you to see and hear. And, so that's the other piece of this, which is really interesting. It's not that you see a snake and then fear is triggered and you scream and run away. It's that you hear you hear leaves rustling, and you're in the woods, and your brain is making a guess about what's going to happen next. And so that guess,
and it's automatic. Yeah.
That guess, yes, it's automatic. That guess begins as your brain preparing you to run. And as a consequence of preparing you to run, it's preparing you to see a snake. So actually, your experience follows your bodily change. It's not that you have an experience and you evaluate it and then you have a bodily change. It's that the first thing that's happening is your brain's preparing the bodily change. And then it's guessing, what are you going to see? What are you going to hear? And so on. So I just said one other thing is that you asked me about the amygdala. So the amygdala's role is really to signal the rest of the brain if you can't make a good guess. Like maybe there's a lot of uncertainty that your brain just can't reduce the uncertainty because there's a lot of ambiguity, or maybe it's something you've never encountered before. So when I show people the blobs, if I was measuring the activity in the amygdala, it would probably go up for a lot of people because they don't know what they're looking at. There's a lot of uncertainty. And what the amygdala is doing is signaling the rest of the brain to say, okay, when that sense data actually arrives, finally, learn it, take it in, because that will let you predict better next time. So the amygdala has many jobs, but one of its important jobs is to basically signal the rest of the brain that something is uncertain, and information that's coming in will help to reduce that uncertainty. So learn it so that you can use that information to predict better next time.
Would it be closer to the truth to say that when someone talks about an amygdala hijack, it's more accurate to say it's a physiological form of hijacking?
There's no hijacking.
Well, the body's automatic. When I'm using hijacking in the sense that it's an automatic reaction.
That's true. But if you want to call that hijacking, it would mean, though, Larry, that you're being hijacked right now. Just breathing is hijacking because breathing is automatic. You don't have to think about doing it. It would mean that your heart is beating now. You have no awareness that your heart is beating. You can't control your heart beating. I mean, you can try to control it by changing your breathing. That's the only way that you can try to change. But that's why scientists and physiologists called it the autonomic nervous system. Autonomic as in automatic. You have no control over it.
I think the hijacking for me is the sudden surge of a change of state, immediate change of state that I'm unaware of.
But basically, I guess what I'm trying to say is that's how it happens all the time. And to call it a hijacking when it's an intense change that you notice, but not to call it not a hijacking when it's exactly the same process, but just a little less intense, so you might not notice it as much, is a mistake.
Got it. Okay. I guess I'm trying to separate a feeling, a physiological, what's happening to the body, and a labeling. Would that be a mistake to separate the labeling from the feeling? What part is constructed, the actual labeling of what this is, this experience, or are we talking about the feeling itself?
No, you're doing something that commonly people do, which is they say, well, if it's triggered, then it's real. And if it's constructed, then it's made up. And I guess my answer to that is, that's wrong. Right now, you're looking at something and you're seeing images. You see colors, right? For example, you've got like a gray lamp, and you've got you've those pictures on your wall, and they're orange and yellow, and so or you look at an apple, it's red. You're not detecting red in the world. Your brain is constructing an experience of red. There is light that's hitting your retina, and that light is not redness. That light is light, and in order for you to see red, your brain has to process those signals. So your experience of red is constructed by your brain with those signals, but also with signals that are only in your brain. That's how you see everything. That's how you hear everything. So for example, like I used in How Emotions Are Made, like that old parable, like when a tree falls in the forest and no one's there to hear it, does it make a sound? Well, the answer to that is no, it doesn't make a sound. Sounds are not in the world. Sounds are in the relationship. A sound, the quality of a sound is in the relationship between those signals in the world, that those changes in air pressure that happen when the tree hits the ground and the signals in your brain that make sense of those signals from the world. The sound is a combination of those two things, those two sources of signals. And that's true for everything you see, for everything you smell, for every touch you feel, for everything, including emotions, but not limited to emotions. So, for example, your experience of what's happening in your body isn't in your body, it's in your brain. That is, your brain has knowledge, memories of past experiences, and it's also receiving signals, electrical signals and chemical signals from your body. And so your experience of your heart pounding isn't in your body, it's in your brain. Your experience of taste on your tongue isn't really on your tongue, it's in your brain. Just like your ability to see, seeing isn't in the world, it's not in your eye, it's in your brain. This is something people don't understand. And it's one of the great beauties of how brains are like masters of deception, right? Our brains are brilliant organs because they create experience in this really seamless way, making us believe that our experiences of the world reveal how it works when they don't. So that's why I was saying about, the body keeps the score. The body doesn't keep the score. The brain keeps the score. The body is the scorecard. You don't feel anything in your body. You feel it in your brain. Whether you have a word for it or not is irrelevant. You have past experience, and that past experience is used to make sense of the signals coming from your body. And when you can't do it, you either don't feel the sensations or you're not sure what they are. So I'll give you an example. A year and a half ago, I had back surgery, major back surgery, open back surgery. They opened up my back, they put in metal rods, they did a whole bunch of shit, then they closed me up. Okay, so after I healed, I knew that what was going to happen was I was going to start having sensations I had never had before because I have metal rods in my back. I'm going to feel them. So I would have sensations and I wouldn't know, well, is that a sensation from the metal rod? I can't tell. So my doctors would ask me, are you in pain? And I'd say, well, I don't know. I'm not comfortable, but I don't know that I would call it pain, but it's uncertain. I'm not sure what it is. So maybe I'll just get used to it. And what happens to sensory signals when they're not predictive of anything is your brain starts to weed them out, filter them out. Your brain filters out sensory signals that are caused by its own movements. That's partly what our cerebellum is for in our brains, that when you walk and your foot hits the floor, you're not feeling the full force of the sensory changes in your feet. Because if you were, you'd never be able to walk. So your brain kind of filters them out. And so I knew after a certain amount of time that I probably would stop feeling my back. But it's not going to take a day or a month or a year. It's probably going to take 3 years or 4 years. When I had my teeth fixed, anybody who's ever had their teeth, anybody who's ever had a filling or a tooth pulled knows what I'm talking about. It's like there's this weird feeling in your mouth that you've never felt before, and your tongue keeps probing it. And you're not supposed to touch it, but you can't help it because you're just so unusual, and you keep probing at it and probing at it. That's because your brain is trying to recalibrate itself. It's different sense information there, and it's learning that, and eventually it will start weeding it out. It'll start filtering it out because it's not useful, and then eventually you stop feeling it. So your brain is manipulating signal. Your brain's a signal processor. It's receiving signals all the time from the sensory surfaces of the body. And then it's got to do something with those signals to make sense of them. That's what's real. And every experience you have as a consequence, including emotions, is real in that way.
But we're constructing the whole ball of wax, the feeling and the emotion.
We are constructing the whole ball of wax.
You're blowing my mind, Lisa. So how does this relate? This is because of the body budget, is that right?
Well, it's not because of the body budget. Body budget is just a metaphor, and I'm happy to use that metaphor, but I just need to say, all metaphors are wrong. This is a good metaphor for its purpose, but it's only a metaphor. There are more technical terms I could use, but basically,
well, I'm trying to give a reason for the bad feeling, for example.
Well, a bad feeling happens. We're not really sure exactly what the mechanisms are, but one of your brain's most important jobs is coordinating and regulating all the systems of your body. You've got billions of cells. They all need oxygen. They all need glucose. They all need a whole bunch of nutrients, but they all have to be coordinated with each other. And that's partly what your brain's doing. It's coordinating in a metabolically efficient way. And metabolic efficiency is a really important thing for all animals, including humans. Because if you have inefficiencies, it's like a little drag on the system. It's like you pay a little tax, and it adds up slowly over time to become diabetes, heart disease, depression, certain kinds of cancers. I mean, metabolic efficiency is really important. So your brain is trying to do its job in the most metabolically efficient way, and it's trying to direct the body to do its job in the most metabolically efficient way. So you can think about what the brain is doing is running a budget for the body, because it costs something to keep your cells alive. That's called your basal metabolic rate. And every time you move, it costs something. Every time you learn something, it costs something. Every time you have to keep yourself afloat in uncertainty, it costs something. But there's also deposits, right? Because you eat, you sleep, and there are savings too. Like it turns out some things are much cheaper metabolically to do when you're with someone that you love and you trust. And some things are more expensive to do when you're with someone that you don't. So, for example, if you
more psychic,
no, metabolically costly, like literally
energy expense.
Yeah, exactly. So, for example, if you are in a situation that is socially stressful, within 2 hours of eating a meal, that meal is digested in a less efficient way to the tune of 104 calories. That means that if nothing else convinces you, not to read the newspaper at breakfast, it should be this, like 104 calories for 3 meals a day times a year is 11 pounds. That means if you live in a stressful situation, okay, and it's persistent, you could eat exactly the same thing as you always have, exercise exactly the same way as you always have, but you will gain 11 pounds.
Because the body is moving resources elsewhere.
The body is not, it's because digestion is a set of motor movements. I mean, you're not moving your limbs or your legs, but there's stuff inside your body moving. Okay. And that movement is less efficient. So you can think about things as deposits and withdrawals, savings and taxes. And you can think about mood. We think about mood as like feelings of being pleasant or unpleasant, feeling worked up, feeling calm, those kinds of feelings, simple feelings. They're not emotions because they're with you every waking moment of your life. I mean, these are the feelings that come from just your body working the way it works.
Oh, okay. So let's use an example of depression. So why am I depressed, or what is the system doing? Yeah.
Yeah. So let me just say, so this is the hypothesis, and
sure,
I can't say this is proven, but there's like a ton of evidence to suggest that this is a very viable way of thinking about depression. Even some of the treatments and why they work also fit within this way of thinking about it. But this is not, I wouldn't call this a theory, right? This is just like a set of ideas that really have to be tested. But so far, it's looking like pretty good. It's looking like a pretty viable.
We're putting in the framework of constructed emotions here.
Yeah, I just want to make it clear that I'm not saying this is true. I'm saying this is, I think, a really good idea. But here's what's happening. When you run a deficit in your real bank account, what do you do? What do you do?
Got to move money around.
Okay, you try to move money around, but let's say
make more.
Cut your spending. You cut your spending. Okay, what does it mean for a brain to cut its spending? It means you don't move as much. It means you're fatigued. It means that you don't learn as much, that you're confused maybe, or muddle-headed, like you're fuzzy. Your brain might go with its predictions. What you see, what you hear, and so on might be really largely influenced by your brain's own predictions, probably not accommodating or changing to the world around you very much, because that's expensive. The most expensive thing your brain can do is move your body and learn something new that you didn't expect, or survive in circumstances of high uncertainty and ambiguity, like political uncertainty and economic insecurity and a pandemic. I could go on, but basically people are feeling like shit right now, not because their fight and flight circuits are overrun, but because they're metabolically compromised. Their body budgets are running deficits. And at the extreme, people, what they experience, the negative mood, the fatigue, they can't move their bodies. They're really dragged out. They can't concentrate. They are what's called context insensitive. So they're misperceiving what's going on around them. All of those things you can think of as a consequence of having a profound bankruptcy in your body budget. Basically, you are metabolically compromised. And you might be metabolically compromised for lots of different reasons. And the actual physical compromise, there are many, many, many things that can cause this to happen. And some medications, for example, like serotonin. So one of the common drugs to use for treating depression is a serotonin reuptake inhibitor. Serotonin is the neurochemical. Well, serotonin is a metabolic regulator, my friend. It evolved as it's not a mood chemical. It's a metabolic regulator. It's helping the brain and the body with metabolism. So I guess what I'm trying to say is that the cause of depression is that there's a physical cause. Oftentimes, depression goes with a compromised immune system. Why? Because the immune system is super expensive to run. If your immune system gets involved and your brain believes that you're sick, you're running up a deficit already. I mean, it's just super expensive. So if your immune system is involved and you have a lot of inflammation and so on, which goes with depression, and it goes with almost every metabolic illness, actually. That's because you're putting a drag on the system, and metabolically speaking. So I'm not saying metabolism is the only thing that's important here, but it's a big, huge missing piece of the puzzle. And I've written about this, that if you start thinking about depression in metabolic terms, you do different things than you would if you think about, the common narrative for depression is that you have overactive emotion circuits in your animal brain, and you have underactive control circuits in your very human cerebral cortex. If that's what you believe, then you do a set of certain things. And if you think about this more in terms of metabolism, and you don't think about subcortical areas as animalistic, and you don't think of them as motion circuits, and you think about them in terms of, your brain is regulating your body, that's its most important job, then you start doing different things. And I'll just say two things about this. One is that I didn't come to this idea. I didn't pull this idea out of my ear. I had a child who was depressed, and I needed to figure out how to help her. And so I went to the literature and I started reading like a fiend, which is what I do when I have a problem and I don't know how to solve it. One of my aha moments was I was at a talk and I was listening to someone talk about cortisol being a metabolic regulator. It's a glucocorticoid. It gets glucose into your bloodstream quickly when your brain believes that you're going to have to expend energy really fast. And I thought, everybody talks about cortisol as being a stress hormone, but it's not a stress hormone. It's a metabolic regulator. It's getting glucose into your bloodstream quickly when the brain believes that you're going to have a big expenditure. That means stress. What is stress? Stress is just a situation where your brain believes you have a big expenditure to make. And sometimes that stress is good, like when you exercise. And sometimes that stress is bad, like when you're in a board meeting or you're, at the grocery store or, and you experience threat, which is your brain telling you that you have a big metabolic outlay. That's what it's predicting is going to happen next. And sometimes it doesn't happen, which if that occurs for a long enough time, it really throws your whole system out of whack.
Because you're not using that particular fuel.
Yes. And then your cells become very insensitive to cortisol. And then you basically have problems with energy regulation, which is depression. And it's a whole bunch of other. So it's not like you could have problems with energy regulation and develop diabetes or develop heart disease. And, do you know what the comorbidity is of heart disease and depression, of diabetes and depression? It's very high. And doctors ask questions like, well, why does heart disease cause depression? And why does depression make people more vulnerable to heart disease? And the answer is, that's the wrong question. There's a common cause there. They're metabolic problems, and they're causing both sets of symptoms.
Now I'm curious about your daughter. And from that conclusion, how did you help her? What was the...
Well, it wasn't one thing. That's the other important thing to understand, is that we're talking about a complex system here. So there are lots of causal factors. They're all weakly related to the outcome, to mood. But when they interact together, they produce a very big effect. And so I just threw everything at it. I made sure, first of all, I didn't realize that she was having trouble sleeping. And so we fixed that with drugs. If you don't get enough sleep, that's just bad with a capital B. Yeah. You're going to feel like shit. And if it goes on for long enough, it's really going to wreak havoc with your body budget. So there was that. There was making sure that she got exercise every day and that she was hydrated well. And we did put her on a serotonin uptake inhibitor, because serotonin, this neurochemical, it's also chemical in your body, but it's also in your brain.
So there was a majority of physical approaches to her mental.
And then there was also yoga and breathing,
movement and
breathing. And there was massage, and also getting her out of situations that were going to be taxing to her body budget. And I don't mean like treating her with kids' gloves, but, she was being bullied at school. And we basically pulled her out of school. We pulled her out of school early. Like we told the school that she was going to graduate early. And they gave us a whole song and dance about how she would make it harder for her to get into a really good college. And we thought, well, better that she be alive and go to maybe not the college of her choice, her first choice, than the alternative. Yeah. And so she graduated early from high school, and she enrolled in courses at BU, the night school at BU. And she would take the bus or the subway down to my office, and I would drive her to her night class. We'd have dinner together downtown. This was like 3-4 days a week. I mean, disrupted our whole family life, but I basically took her to class. I sat in a coffee shop and worked. She went to class. I drove her home. We did it again. We did that for 4 months. Then
you're a great mom.
Well, thank you. But I mean, if I was a great mom, I feel like maybe I could have avoided all of this altogether, and then there were other really smaller things. Like I made sure she understood that the world was a big place, and that part of what happens in depression is that your brain can't predict very far ahead. It's like you're looking at you're sort of looking into a brick wall that's really close to your face. It's like,
your perspective narrows.
Perspective narrows. Yeah. And so I tried to help her see that the world is big. I tried to explain to her that the physical feelings that she was having, are actually kind of the same as the feelings that you have when you have the flu. It's really similar, actually. But you don't hate yourself when you have the flu. You don't don't berate yourself. No, you just wrap.
You're sympathetic, right? You understand.
Yeah, exactly. So she's the one who came up with the idea of a new concept called the emotional flu. The emotional flu is,
I like that.
I don't feel good. Everything feels bad to me. I'm tired. I'm fatigued. I feel like shit. The world feels like I'm looking at the world through opaque glasses.
Color, yeah.
But I know that this doesn't mean that anything is wrong with my life. It's just a physical feeling.
My system is constructing all of this.
And she is making sense of those sensory signals as my body budget is out of whack and I need some deposits. So I'm going to take it easy on myself.
I like that.
I'm going to make sure I get enough sleep today. I'm going to make sure, right? So one time we were traveling because I would take her with me on spring break. I would take her with me wherever I was going. And so she could see the world was a big place. And we were in Stockholm and we had a really hard flight getting over there and we almost missed our flight and whatever. Anyways, by the time we got to Stockholm, she was a mess. Like I thought she was starting a depressive episode. She was really, really, really depressed. That's the way it looked to me. And I thought, all right. So she woke up and she was just miserable. And I gave her ibuprofen and food and I put her back to bed. And I said, go to sleep. We'll see how you feel when you wake up. 6 hours later, she woke up. She was fine. And again, I want to be really clear. I'm not saying ibuprofen cures depression. But what I'm saying is that her body budget was running a deficit and I made a big deposit and I gave her some anti-inflammatories to try to calm her system down. And then we walked around Stockholm for the rest of the day talking about how it could have been different. Because if I thought, well, this is going to be a major depressive episode if I don't nip this in the bud right now. And then I tried to, and it worked, right? But what if I had said, oh, she's depressed? I would have done very different things. I would have done very different things than the thing that I did. I would have treated her differently. I would have maybe tried to cheer her up, or maybe I would have called her psychiatrist and asked for a higher dose of drugs, or I could have.
But you said you thought she was depressed, so I'm going to give her anti-inflammatory. So
I thought she was. Well, I thought that she was heading for another major depressive episode. But in my mind, what that means to me is allostatic disruption, body budget deficit. That means she needs deposits. And
those are two things. So you did think that, but you approached it from the body budget.
Yeah, because to me, depression is not a mood disorder. It's a metabolic illness.
Right. And that's the reason I want to just clarify what you're saying and how you approached it. Even though you recognized it for our audience, you recognized these are symptoms of classical depression. But I know based on the theory of constructed emotion, I am going to approach it from the metabolic standpoint.
Exactly.
Rest.
Yeah.
Okay. This is really bringing it home to me and maybe the audience, Lisa, is we're taking the framework of constructed emotion, but applying it to a real world situation. And things are starting to click for me and I hope for everybody else. Lisa, I wonder how many people in the world I can imagine that think they're clinically depressed when they're just sleep deprived. It's got to be a huge number of.
Yeah. Well, I will say though, that sleep deprivation after a very small amount of time can give you the symptoms of clinical depression. But yes, exactly. I mean, I think I went 15 years of my life being sleep deprived when I thought I was miserable, but I was sleep deprived.
There's probably some football coach. Fatigue makes cowards of us all. I mean, there is this connection.
I think the important thing here to understand is that when your brain is making a set of predictions, really what it's doing is it's creating an explanation for what it thinks is about to happen. It's making an action plan. So when you change your predictions, when you change how you understand what's happening to you, your action plan changes. And that's what's important here.
Is that where cognitive therapies come into play in the prediction side? Okay.
Yes, exactly. Because you have to think about your experience and your actions as a trajectory. It's like it's not just what you do in this second. What you do in this second makes the next second what you're going to do in the next moment, certain things harder or easier, right? So really what you're doing is your brain is creating a story for itself about what it thinks is happening and what it should do.
And it's going to react based on what it predicts is going to happen.
Exactly.
Okay.
So, like when I was in my early 50s, I went to the doctor. I was feeling very fatigued. And I went to the doctor and I said, I'm really, really fatigued. This was a new doctor, very fatigued. And he said, well, maybe you're depressed. And I said, yeah, maybe I am, but I don't think so. I'm not really experiencing negative mood exactly. I'm just really tired. I mean, I was feeling unpleasant because I was so tired. And nothing's really wrong with my life. I'm just really tired and I just don't have the energy to do anything. And like, I kind of, I'm starting to feel apathy because I'm so tired. And he's like, well, maybe you're depressed and you don't know it. And I was like, well, maybe that could be it, but I don't actually meet the DSM, like the diagnostic criteria for depression. I don't think I'm depressed. He's like, well, let me just give you some antidepressants. Okay. So I think thinking to myself, this guy's not listening to me and I'm not going to see this doctor again. And as I'm leaving, the nurse calls me aside and she goes, honey, could you be going through menopause? Because, here's a book that you should read. She gives me the self-help book about going through menopause. And sure enough, wouldn't you know it, I was going through menopause. Estrogen, progesterone, testosterone, they all have metabolic effects. So I didn't take the antidepressants and I did a bunch of other stuff instead. But let's say I had believed the doctor. Oh, the doctor was basically constructing my experience for me. You're depressed. That's what your symptoms mean. You're depressed. I would have taken antidepressants and that would have led me down a very different trajectory than the trajectory that I took. So I could give you the example that I talk about in How Emotions Are Made. People have test anxiety. There's so much uncertainty and there's so much arousal. Arousal comes with uncertainty because your brain is attempting to prepare to learn, prepare to take in new information. And the neurochemicals and the physical consequences of that are often, we feel it like as feeling jittery or feeling worked up.
So anxiety is a preparatory mechanism.
For learning. Yeah. For uncertainty. It's like a response to uncertainty and your brain's attempting to, yeah. So in test anxiety, but if it's too much arousal, you can't take in new information and you can't perform well. So, and I'll just say test anxiety is not a trivial thing because some people who suffer from test anxiety can't finish college. And if you can't finish college, it changes your earning trajectory for the rest of your life to the tune of hundreds of thousands of dollars. So helping people construct different experiences from the same signals, the same arousal signals, is really important. And there is this research by Jeremy Jameson that teaches people how to construct determination instead of anxiety. And these people learn to make sense of their physical state in a different way. It's not just learning a new label. They're learning.
Are you recategorizing feelings?
Yes, you are recategorizing. Yes, exactly.
This is great because I wanted to ask you, one of the questions I have is about, has someone created some kind of schema for predictions? You know what I mean? Some kind of map.
He uses different language. He doesn't call it categorization, but that is what is happening. And then, so the arousal levels don't go down. They just mean something different. And people are able to take tests.
Like I'm excited versus afraid. Or
exactly.
I'm going on a roller coaster versus taking a test. Does that work? Did it work? Is he?
Totally works.
Okay.
It totally works. I mean, right before I gave my TED talk, when I was backstage, I could feel my heartbeats in my fingertips. Like that's how ramped up I was. My arousal levels were through the roof. Okay. Because I was about to walk out to a stage, 900 people. I just kept telling myself, this is determination. This is what determination feels like. This is determination. And, I talk about this in the book, and I think I may have even said it in the TED Talk, but I conjured in my mind, my daughter, when she was 12 years old, was taking a black belt in karate. And at her test, she's this tiny little thing when she was 12, and she had to spar with these like hulking, 16-year-old boys who were like a foot taller than her. And her sensei was a 10th degree black belt. This guy was so strong, he could just look at a board and it would break. Okay. Like this scary dude. But he said to her, he goes right up to her and he goes, "Get your butterflies flying in formation." And I was like, that's actually the most brilliant thing I think I've ever heard anybody say. Like, he didn't say, don't be scared. He didn't say, calm down.
And he wasn't denying that the butterflies are there. Yeah.
No, he's saying, get your butterflies flying in formation. And so in that moment behind, the stage, I'm waiting for them to call me out. I'm like thinking to myself, this is me getting my butterflies flying in formation, because I have a like tsunami of butterflies going on right now.
Because they do have a purpose, to your point. There's a purposeful, there's some intelligence happening here that
your brain is preparing you to do something hard. Sometimes when you feel uncomfortable, Larry, sometimes when you feel bad, it doesn't mean something is wrong. It means you're doing something really hard. So there's not an infinite number of ways to recategorize your physical sensations, but there is more than one way that fits the situation well.
The last thing I just want to ask is, because you talk about semantic markers and Antonio Damasio in the book. So a lot of times I think the more emotional I am, the worse my decision is going to be. But at the same time, Damasio talks about in Descartes' era, the patient Elliot, who loses there's an injury to his frontal lobe, and his ability for emotions is kind of eradicated or what have you, muted, and he makes terrible, terrible decisions. So emotions are very important to decisions. So my question is, how do we use emotions correctly in the decision-making process?
I think you have to make a distinction between mood or affect, what we would call these simple feelings that come from the state of your body, and emotion. Because what Eliot lost was affect. He lost the ability to feel moved. He didn't, right? And so that means that he lost emotions, but he also lost aspects of consciousness, meaning, I don't mean he went to sleep. I mean, you have features of conscious life. Lights are bright or they're dull. Sounds are loud or they're soft. You don't feel the sensory consequences specifically of all the things going on in your body. You're not really wired for that. And also, if you did, you wouldn't pay any attention to anything outside your body ever again. There's like a whole drama going on right inside you right now, Larry, inside me, inside all our listeners. But we don't feel it because we're not wired to feel it. And if we do feel it, something's really wrong. So I would say that, evolution has provided us with kind of a barometer of what's going on inside our own bodies, since we don't have access to all the little details. And so that's what mood is. That's what these simple feelings are: pleasant, unpleasant, comfortable, uncomfortable, worked up, quiet, and calm. That's called affect. Those feelings are called affective feelings, or they're called mood. They're properties of consciousness. They're not emotions, but we tend to create emotions with them when they're very intense. So when there's a big metabolic change, we have a big shift in affect, and that's when our brains tend to make sense of those changes as emotions. So affect is always with you. If you have a neurotypical brain, it's always there. And decision-making and rationality are not in opposition to those feelings. They're part of those. The rationality can't be separate from those feelings, because your brain is wired in a way that there's something wrong if you don't have those feelings. If you don't have those properties of consciousness with you all the time, that means that your brain isn't neurotypical anymore. So that's what Eliot lost.
So do you think intuition then is a form of intelligence that we can
Well, I think that intuition can help you or hurt you. I think affect can help you or hurt you. Okay. I think the way that you make sense of affect can help you or hurt you. Like, I don't think about rationality. If you ask people to define what rationality is, they tend to define it as the opposite of emotion. That's not a biologically viable definition. And I talk about this in 7.5 lessons. So somebody who's suffering from PTSD, their brain is predicting threat because they've experienced threat in the past, and they believe that there's threat. And so they're preparing for threat. It's a very rational thing to do, to prepare for threat. If the base rate of threat was high in the past, or you had a dramatically intense experience of threat, like something, some moment of adversity that really put you at risk, then you never, ever want to experience, you always want to prepare for that and make sure it doesn't happen to you. So that's a very rational thing to do. The problem there isn't that the person is irrational. The problem is that their brain is making predictions that don't fit the situation that they're in. And that's not an issue of rationality or not. That's a problem for them, but it's not an irrational problem. Like, it's not a problem of irrationality. So I guess what I would say is, when your affect is strong, when you like very, very intense pleasantness or unpleasantness, it tends to make us believe that whatever we're experiencing in that moment is real and will always be that way. And that's something called affective realism. Like, you believe your own experiences more when they're very intense. if you're talking to me and I have a very, very strong negative experience, I'm going to believe that you're not a nice person or that you mean me harm, because my brain's trying to explain that very strong feeling, and I will believe that explanation, right? So when somebody cuts me off on the highway and I have an intense response to that, I tend to think that, the person who's driving the car is an asshole for cutting me off.
If I make a decision, then I need to be at some form of stasis or equilibrium versus the highs of either.
I try to remember that, like, if you feel very, very pleasant, it's probably because you just got something that you wanted, or somebody said something, or you read something that matches your own deeply held beliefs. Or if you feel really, really unpleasant, it's because somebody violated your deeply held beliefs. It doesn't mean that what you think or believe in that moment is true. It just means that it's affecting you very strongly. So the interpretation, like when somebody cuts me off on the highway, my immediate response is to think they're an asshole. But I try to stop myself and go, okay, anger is a form of ignorance. Maybe that person didn't see me. Maybe that person is rushing to pick up their kid who's sick. Maybe that person, mother is dying in the hospital. Like, there could be 100 explanations other than that the person is not a nice person. So one of the things you can do is it's not that you make bad or good decisions. It's that when you have very strong affect, you just interrogate your decisions a little more. And you try to think about those decisions. How would you make those decisions in different situations? So you deliberately kind of open it takes a little bit of effort to do it.
Take the feelings into consideration, but do consideration, do the evaluation.
Exactly.
Well, Lisa, I feel very good about this interview. This was very deep and a little bit complex, but I think we landed the airplane. That was very helpful. Thank you for coming on.
You.
Where should we point people to? Just your books?
Actually, if you go to my website, lisafeldmanbarrett.com, all the books are listed there, or I should say both books are listed there, but from many different sellers in many different languages. So you can pick where you want to.
And you have some articles and some essays there as well.
I have a lot of articles and podcasts and so on that are freely available. So, people can read about the ideas and about the scientific studies and so on without having to buy the books.
Thank you.
Thanks
so much, Lisa. All right.
My pleasure. Thank you.
Take care.
Okay.
Cheers.
Bye.
Bye-bye. Well, that's a wrap. Thank you for listening. If you enjoyed it, do share it with your friends and on your social platforms. Big thanks to Sam Williams, my audio guy, and the beautiful bumper music you're hearing is Michael Petrovich's Bella Luna. For all my show notes or resource links, visit larryweeks.com, and we will talk again soon.